I need some energy in the room. Are you guys ready to get started? Say yes. Woo!
Nice. Thanks for the love, guys.
Turn it over to Mr. Matt from
Thank you.
Deloitte.
Thank you. Okay, so before we get into the hybrid AI intelligent routing, let's just start with who here has heard of ChatGPT? Okay, good. You haven't been living under a rock for the past couple of years. That's awesome. So if you're familiar, even at a high level, right, with ChatGPT and how large language models work, most of the time it's being trained and inferenced in public cloud. So there's a headline here that says, what would it take to enable AI inferencing everywhere? And so it's important to understand that there's a distinction between training, right, really complex inputs into large language models and actually making those large language models better, and then executing, right, the inferencing, AI using its brain to deliver functionality. And so as AI is kind of scaling both to private cloud and data centers and to the intelligent edge, and I'm thinking about this is a data center, but intelligent edge could be anywhere. It could be inside a factory, it could be inside a retail store. You're still sitting on server infrastructure. But in the past year and a half, companies like Intel have introduced the AI PC. And sitting up here talking about this problem space, I can't help but reflect on once upon a time we were trying to scale the internet, and we conceived of content delivery networks where obviously things were starting centrally and ultimately cached to the edge and even to the far edge. And I don't think what we're doing here is too dissimilar. The question is, how are we going to do it intelligently, right? And so that's really where what we've done in this proof of concept and this problem space together with Deloitte and Intel is to figure out how we strategically route those workloads from cloud to data center to edge to the PC. The demonstration you'll see is largely going to be sitting between like the data center and the AI PC device, but that's okay. In the end, this is what we're shooting for architecturally in terms of how we're going to collectively scale AI. So I think maybe taking a step back before we get into the actual demo or the application that we've built which demonstrates hybrid AI. So a couple of trends. First off, efficiency of AI models. I'm not sure how many folks in the audience are following all of the iterations that are going on with proprietary models, open source models. The foundational models are changing constantly, if not every quarter, every month. And in those changes, right, these models are becoming faster, more efficient, and more importantly, smaller, right? That's important because at the end of the day, the AI PCs are getting better. That's really the second point, right? Which is these devices are becoming increasingly more capable of running larger models. At the same time, the models themselves are becoming smaller. And then of course, which we'll talk about a little bit more in a moment, applications to tap into these capabilities are being developed right now, right? And so in addition to the trends, I think it's also important to highlight a few like opportunities that we essentially are looking at when it comes to hybrid orchestration. So folks who might have attended the keynote earlier today probably heard Tyler Saltzman talk about his company and how they are working with military, right, to essentially tap into data privacy, right? They don't want any of those inferencing workloads going over the wire, right? So you've got, I think, a very specialized industry context that is saying, look, that can't happen. And then I think there's also another trend where we're seeing other use cases, and it's like, hey, we might have choppy or intermittent connectivity, and let's make sure that AI functionality can exist even when that connectivity is either like just either choppy or not available, right? I'm a consultant, I'm on planes all the time, and I can tell you from experience, airplane Wi-Fi, at least until Starlink gets there, is not necessarily where I would need it to be to run these kind of applications. But the thing that's really interesting to me is this middle point. Now, admittedly, cloud costs and how to do inferencing in the cloud has gone down over time. But at the same time, I think there's also opportunity costs that we should discuss, right? A lot of companies, whether they're looking at their own private data center infrastructure or their cloud costs, they want to make sure that those resources are made available for really complex inferencing tasks, or as I mentioned before, training, right? And so there is the added advantage of using something like the AI PC to free up that very expensive GPU infrastructure. So then let's talk a little bit about like hybrid orchestration, what it is and how it works. So if you look at this diagram, this is instructive in terms of what we've built with Intel over the past, really the better part of the past year. So it's first asking a key question, is connectivity available? And if the answer is yes, well, then we need to ask, is this query or AI inferencing task something that we should use our valuable server infrastructure for, or should we maybe keep it locally on the AI PC? And if we're doing, say, the server-side inferencing, well, then we're going to be using a more robust model, right? In this case, we've been using a 70 billion parameter version of Llama, and we've onboarded that using Opia, and that's great. But at the same time, if we're saying that this is not such a high fidelity question that needs to run on server-side infrastructure, well then we're tapping into the AI PC. And even within the AI PC, we've introduced logic to say, look, like we have made it a point to be able to get to a 7 to 10 billion parameter model that can run on a PC. But maybe your battery is running low, maybe other compute resources are taking up other tasks in parallel. And you might want to point it to a lower fidelity model, such as a 1 to 2.5 billion parameter model. And so I think it's important to realize that having the ability to dynamically shift between these different models on different parts of infrastructure is important. Because at the end of the day, again, this is how things are going to scale. Probably also worth mentioning, we did work closely with Intel using OpenVINO, both to implement these models on the device, and on both of these pictures on the diagram, we've implemented a RAG architecture so that the LLM can effectively tap into specific data that's unique to our enterprise as Deloitte. And I'll get into what that is in just a moment. So let's talk about the application that we developed, right? So what we wanted to do was essentially roll out something that was simple, effective, that users could look into basic tasks and prove the value of that architecture that we developed. And what we landed on as a really cool proof point was something like ITSM, IT Service Management. And so this is essentially an application that essentially is a chat interface and taps into the questions that a Deloitte practitioner would ask, or a Deloitte IT help desk person who would essentially like input the command and run that query and put it through the large language model, and then do that either using direct voice or speech to text, right? I think one of the other things that I would comment on is maybe the user interface, right? So if you take a look at the input here, right? It's essentially an input from the user, either using voice or using just a text prompt. And essentially, like at that point where we're going for low latency and maximizing the user experience. So basically, if you were to run this locally on the device, one of the key observations is that it's actually faster to do it than the round trip that you would see go into the cloud. And you want to be able to ask this application a couple of varying questions, like, is my Bluetooth operating effectively? How do I introduce a new Bluetooth device? Am I in compliance, right, with all of the latest applications? How do I troubleshoot my mobile phone if I'm having issues getting a Deloitte application onto it? So you want to be able to essentially ask all of those various things. And then as the actual inferencing is happening, we're indicating whether or not we did that on the device or in the cloud. And so it was a pleasure to execute this with Intel. If you are interested in like a live demo, just come by the Deloitte booth right over here. I'll give everyone a live demo of this, but just wanted to capture a couple of screenshots and just articulate what we were able to do here in a very quick period of time. Before I talk about the roadmap, maybe I'll just ask the audience any questions that came to mind, because I saw, I opened up with some questions, but many others have kind of filtered in as I've been talking. So just maybe any questions from the audience, if I might.
We got to get the mic so it's on the recording.
So AI PCs includes CPUs, GPUs, NPUs.
Yes.
Are you orchestrating between those three, and if so, how?
So the answer is the focus of this is NPU, because obviously that is where we're trying to get the most efficient AI inferencing out of the AI PC. But at the same time, we have routed traffic to CPU and GPU as well. So OpenVINO accommodates all of them, but I will say NPU was the focus. Yes. Other questions?
Any other questions? What other questions we got for Matt? Yes.
So I'm sorry, I didn't get here for the start. But
Oh, no worries.
I'm curious, when you're looking at running these hybrid workloads, do you have any of the economic information about when I move work to the endpoint, what it means economically in terms of savings in the data center? Do you guys have studies on that can really pinpoint why I want to spend more on AI PC?
We absolutely do. And at the beginning, one of the points that I made was it's not just about the cost, but also the opportunity cost, and wanting to make sure that you free up those GPUs in the data centers. But we have done some basic application, just traffic sniffing to say, look, like this is the cost per token, either in terms of capital spend in the data center or in OpEx if you're running in public cloud. So yes.
Nice. Yep. Question in the back.
It's okay. No. Are you storing the 3,000 knowledge base articles and then also running the vector DB on the AI PC, or is that happening on Xeon, right? And then the inferencing running on the AI PC?
So the answer is both, right? We used OPIA, right, to do the RAG pattern of the Deloitte IT articles in server infrastructure, and we did it on the device as well.
Oh, you were able to get that on device?
Yeah, absolutely.
Okay.
In fact, it's been in on-device AI generally a good way for us to introduce this kind of specialized AI functionality without having to fine-tune these small to medium-sized language models that go on the device. And so, yeah.
Okay, thank you.
Other questions?
All right. Oh, you're still going.
I am. I wanted to take questions just in terms of like the here and now.
We got about 2 minutes. Just.
Oh, thank you.
You're welcome.
Yeah. So we're not done, is I think my point. And I made it at the beginning that this is just the start of the hybrid AI journey. We talked about on-device AI. We talked about the fact that we've now introduced intelligent routing. a few things that I think are important to cover off just in terms of where you see where we're going next. This was all about like IT help desk, but we actually think that this architecture could fit in a multi-agentic format where we might introduce other agents using a similar architecture that are able to route to one another. So I think that's important in terms of our vision for where we think this is going. Self-learning and dynamic routing, obviously, you saw the traffic patterns in terms of how we're making those determinations on whether to go to the cloud or to the device. There's some reinforcement that is important with like up likes or down likes and things of that nature that are important to make sure that we get the accuracy of this right moving forward. And then dynamic data accessibility. Admittedly, this is a proof of concept, so this was executed as a download of a few thousand Deloitte IT articles. But that was a one-time thing. To actually put this into practice, those articles need to refresh each other, right? And that's how this sort of capability essentially scales and unlocks the promise of hybrid AI, right? So I wanted to end on that note. Thank you all for your time. It's been a pleasure speaking with you, and have a great rest of Intel Vision.
Woo! Let's give Matt a nice warm round of applause.